Okay, so this is the home of Atlas. If you, the first step to do generally is create concept sets because they'll be used into cohorts, but I'm going to skip that and just go to the cohorts for now. So when you go to the cohort tab, you'll end up with a table that has all your cohorts that have been created, and you can go to this new cohort as I showed you earlier to create a new cohort, but I'm going to cheat and go to PLP cohort that we've already got. So I've already created a cohort, well, Patrick already created a cohort and I just copied it across for PLP training. So we've got our T cohort here. So we click on this link, it will actually come up with our definition. So in this cohort, we've defined it as people who have a condition occurrence of atrial fibrillation for the first time in their history. They have to have 365 days prior observation. We're going to look at the earliest event. So this is the T0. We're only looking at the first time they have the atrial fibrillation. And then the inclusion criteria, they have to be aged between 65 and 95. They have to have exactly 0 of this any time prior. They have to have 0 of this any time prior. They have to have no surgery in the last year, and they have to have no warfarin in the last year as well. So this defines our cohorts as our inclusion rules. If you want to look at the concept sets and what goes into them, you can actually go to this concept set tab. And for example, if you go to atrial fibrillation, it will then tell you the concept set, how it's defined. So you see here we've got the atrial fibrillation and all its descendants. So you go to included concepts, you can actually see what its descendants were, if you wanted to have a look at that. And we can do this for all the different concept sets that are in this cohort. And as I mentioned, the concept sets get created using this tab. And then once you've created your T, you then want to go to generation. So I've previously generated this in the SimPuff 1%. You could generate in the 1K as well by pressing the generation button. And then you get this pending as it's actually running it. And then once that's done, you'll get the number of people. So in this case, we got about 16,000 people. Here we had 133, so we probably won't be able to do predictions in the 1K. And then you do this similar thing for the outcome. So we can go to the PLP training again. And we get our outcome cohort. So in this one, we've got a condition occurrence of stroke, and they have to have had a visit, an inpatient visit. We don't put any restriction on the observation because we're actually just looking at the outcome now. So when you're looking at the overlap, that will get restricted anyway. And they have to have had 0 stroke in the past 30 days. And again, once you've done that,
can you repeat the inpatient visit condition?
so to how to get it. Do you want? So if you.
I have an ischemic stroke during my inpatient visit.
Yeah. Yes, it has to be recorded during an inpatient visit. And then again, you can go to your concept sets, look at how you define stroke. And in this case, this is how we defined it. And then you can go to the generation. Again, you generate on the 1K. I've already generated it for the SimPuff. So this is your targets population and your outcome population done. So then you want to go to your prediction. And in the prediction tab, you get, again, a table of all the prediction codes that have already been generated, or you can go to a new prediction. So I'm going to go to a new one and do it from scratch. So I'm going to say PLP training, all variables for the CHADS 2. So the existing ones in that table, if you just use the CHADS 2 as it actually is in the paper you reviewed, or if you want to look at it when we reproduce it using the 5 variables using our framework. And now we're going to see what happens if you reproduce it using all the variables. So we can see basically how much we could do an improvement if we didn't restrict to just 5 variables. So we choose our T and our O. So I go to filter and I call them PLP T atrial fibrillation, and then PLP O stroke. So this is our T and our O selected. We're going to do a lasso logistic regression. We're going to stick to the default starting for the regularization, and then we're going to try and predict it with 0 to 1,000 days. That's what it is for the CHADS 5. Then we're going to say they have to have at least 365 days prior observation. We're going to remove people if they were partially observed. So we're going to keep this as yes. We're going to use first exposure. That's actually in the cohort definition anyway, so it doesn't really matter what we put here. Include people of outcomes that are not observed for the whole period, yes. So if someone's got the stroke and then they die, they'll still be included. And then we're going to sample 10,000 people from our target population. We're going to remove people who had the outcome prior to entry, which we don't want to do that. We want to keep people even if they've had the prior stroke. And then we're going to do a person split. We're going to do 25% in the test set and 25% to 75 in the training set. Free-fall cross-validation. And we're going to now select every variable we possibly can, except for index year, because that messes up prediction. So if you're trying to predict the future, if the year's concluded, then, I mean, if you're doing phenotyping, I think it could be good if you're trying to impute, but for the prediction. I mean, Peter reckons that it could be good if you wanted to see if there's a temporal trend and not use the model. You might want to do that first to see if the year's coming up. But if you're trying to do it for an actual prediction, it's best to exclude the year. So we're even going to include the CHADS2 score in this as well.
For conditions, are those checkboxes not inclusive? So if it says if you check all time prior, do you also have to check 30 days prior?
So you'll get variables. So if you look at all time prior, it will look at the whole period. So you'll say, did they have it at any point in the past? If you look at the 30 days, you'll just look at the 30 days. So sometimes there's information about when they had it might be useful. So if you put them all in, you're saying, looking like you have 3 variables for the condition. Did they have it any time? Did they have it last year? Did they have it in the last 30 days? And it will kind of give you some indication about how far back. Interaction terms are problematic because they end up getting a large number of variables if you put these in, because it's going to do all the variables you did plus every month and every year combination. So we generally don't put those in. And then specify a minimum number of subjects, so it's 20. We're not going to do any exclusion or inclusion for the covariates. So this is our, so now we can save this. And then if you go to utilities, and you can see it actually tells you what your standardized problem was, and you have information about your covariates. So you can cut and paste this into a Word document, so you've got kind of a copy of what you actually did. And then if you go to the R code, you get all the R code needed to run it. So you can now copy and paste this R code. I have previously done this, so I'm just going to go to R here. So I've got the connection details. So I can. For what, sorry? So
your concept sets at the end, what concepts do you want to include? You said this is an example of all of them. How do you select all of them?
Oh yeah, so what I'm I didn't put any inclusion or exclusion in, so I'm just using all the concept IDs.
So everything will be pulled in?
Yeah, anything that has at least 20 people have it recorded.
Awesome, thank you.
Around copying and pasting. When you copy and paste your art code into your Art Studio, there are some parameters, some references to the cohort ID, started cohort ID, outcome cohort ID. So how does it work if I'm running on my own data, so the cohort IDs are not going to match?
Yeah, so normally you'd have the atlas connected to the same instance. You got your data, so the cohort IDs, you would generate it and then cut and paste it and it would match. In this example, because we're using the OHDSI atlas but running it locally, I've actually modified. So you'll see here, the cohorts in OHDSI IDs were here, but I've actually changed them to the IDs that we have at J&J. So generally it should just work, but in this case, if you're doing it in OHDSI for your local, you'd need to manually change those.
Thank you.
If I may follow up on that, there was a step in create cohorts. So I thought as part of so let's say I have 0 cohorts created. I don't have Atlas at all, but I can use somebody else's Atlas to give me the SQL code, or I know our code, how I can get to it. So I would want a little code in your 1, 2, 3, 4, 5. There was a step, create cohorts. So are you skipping that step in your R code?
So the create cohorts generally done in Atlas. So I showed the cohorts in Atlas, and you'd generate and it would create them. If you didn't have Atlas set up, but you had the OHDSI Atlas, you could create an atlas
Correct,
and
that's
copy
exactly
and
what I'm
paste
doing.
it into
But I need to
SQL.
call in R to actually create them in my cohort table. What would be that command?
So once you've got, you need to render the SQL to parameterize it to put in your cohort IDs and the table details, and then you would do like query execute SQL from the database connector package. Would run it.
So just run that. Okay, I think I have done that before, but it would be nice to know. So there's an R version, the Atlas way of like a script inside R if you are working with Atlas, but there seems like to be a separate R template script, which if you're not using Atlas at all, which
Yeah,
would be
so-
an interesting thing to have as well. Because at my institution, basically, unless I have 100,000 security certificates, I cannot start a new web server.
So if you didn't have Atlas, what you'd have to do is in this bit where you're saying cohort table, and in this cohort database schema, you just basically have to, in some schema or in some table that you have access to, you would need to create the cohorts with the cohort definition ID, cohort start date, cohort end date, and the subject ID and the row ID. And then I think it should just be personalized subject ID. And then you just have to specify them here once you create them. So you could create them in any way you want. As long as you've got them, you then just specify this is the schema where the cohort's found, this is the table name where the cohort is, and then this is the ID for the cohort. So you can these are flexible. Atlas just makes it so that it just makes it easy, because if you create it in Atlas, generate it, and then run the R code, it should all kind of match. But if you don't want to use Atlas for every step, or you want to use Atlas to create the R code, but you're not using Atlas for the SQL, then you just have to put the corrected values into these settings here.
Just let me just try to restate it in a slightly different way. This framework is trying to modularize the decisions you have to make to design a prediction problem. The first decision you have to make is, what is your target cohort? However you want to create a target cohort is up to you, but we have a succinct definition of what a cohort is. It's a set of people who satisfy a criteria for a duration of time. And we have a specification for how a cohort needs to be instantiated. You have to build a table with 4 fields, and that table has to be populated. That step of creating cohorts is deliberately and intentionally separate from this. So it's not something that this package is doing, because you have to build cohorts to do estimation studies, you have to build cohorts to do characterization studies. But once those cohorts exist, however you chose to create them, this package takes as an input a target cohort and an outcome cohort, and then allows you to use those as input to generate all of the output that Jenna's talking about. What we've enabled in Atlas is you can do all of those things all at once in one experience, but if you want to, or for whatever reason, create your cohorts in a different way, this package is fully supportive of that.
So I'm just going to run this now. So this is the all variables, and it's going to be using a CCA database. So if I source this now, it should generate and generate everything for us and go into the PLP training folder. So it's going to sample 10,000. While this is running, I'm going to show you the results for reproducing the CHADS2 when we used Optum. So you can't run the R code. So you have to, once you've generated your R code, you have to cut and paste it into RStudio, and then you can press source. So this is when we reproduce the CHADS2 using Optum. This is so the CHADS2 paper was 0.68, I believe. It's the C statistics at the end of 0.68, or was it 0.82? Was it 0.82? Okay, so 0.82 was the things when we reproduced using the CHADS2 and R data, we got 0.72. When we looked at using the 5 variables and all the descendants of those 5 variables, we got 0.76. When we looked at using all the variables reproduced, we got 0.82, which is comparable with their performance when they had the score on their own internal. So this is reproduction of that. Now,
A few questions. So let me just try to clarify one thing when we talk about all variables. When we are creating a feature set, we are creating a variable for each diagnosis code, for each drug, for each procedure, for each measurement. a variable for the Charleston index, and a variable for the CHADS2, and a variable for how many visits you've had, and a variable for how many drugs you've had. Each of those are individual features. So when we keep putting up there and said, we just fit a model with all variables, it's all variables that are automatically created using the feature extraction package. So that means you fit a model there that made use of tens of thousands of different covariates that then the model was choosing amongst them.
So all variables is what you threw into the lasso thing? Is that what it is? I see. So you, okay, so you compare, essentially you compare CHADS2 with the lasso models. Okay.
We could use those variables ourselves to look at the concept sets.
So the features that go in when you like click check like all conditions, that's basically saying you are taking every SNOMED concept and treating it as a potential variable. The output, as Jenna showed you when the model is produced, you're able to see every variable you selected. You can see how often it occurred in the target cohort and whether or not it happened in the outcome. And then you'll see whether or not the model chose to select that variable. It's one of the standard output of the file, yep.
The issue of collinearity when you put all variables in.
The question is, what do we do about collinearity? So basically, that's a question that each model makes its own assumptions of how to deal with. So in the case of a lasso penalized regression, basically it's selecting the variables that are most orthogonal. So it's going to, if it finds two correlated variables, it's likely to select one and then shrink the other one down to a beta of 0. But that's a model decision that gets made. So different models will deal with correlated variables differently.
Okay, so this result is for the 5 variables.
Can you open up one of the tables not in the shiny format? So like the raw table that's being pulled up, can you run like a view? Or
So yeah, I can go to some of the results I've generated before. So these are some things I was testing on yesterday. So if once you've actually run this, you end up with an evaluation folder, a plot folder, and saved model. So in the evaluation, it actually has the calibration summary, the covariate summary, demographic summary, evaluation statistics, prediction distribution. So all the outputs that I showed as CSVs.
do you get the raw data set like a patient on a row and like the feature set like matrix?
So you'd have that as the PLP data. So I didn't save that here, but the PLP data, when you save it, will have for each person their
So you,
covariate.
I mean, if there were like 60,000 patients, you would be downloading the matrix 60,000 plus whatever features were selected would be on your desktop.
So we actually have this as a sparse format. So we just have patient ID, covariate ID, and then the value.
1 or 0, or is it?
It depends. If it's a measurement, it could be continuous.
You would have the raw measure.
Yeah.
Right, thank you.
Yeah. So and then you'd have you've got this table that has all the plots. So we can click on here. We can actually have a look at the plot of the rock, and so this I think is all models and Optum, all variables in Optum. Sorry. And then let's see if the all variables, how this is going for the CCAE. So at the moment we're currently extracting because we're using all the variables. It's got quite a lot of the variables to extract, so this will be running pretty for a couple of minutes. But another thing that's worth showing when you output it, so you have all your plots, you have your evaluation, your plots, you have your save model, you have a log that tells you information about your test train performance, you've got your size, so we have a target population of 10,000. There was 33,800 variables that were put in for all the model in Optum. You have 3,600 people that actually end up being in the population, so these other people excluded because they weren't observed for the whole observation and so on. And this tells you how many outcomes you have. It tells you where your results are saved to, and it tells you information about how long each of the process took and the PLP version. Also, one thing we have is this document, which we've ironically named Ready for JAMA. And if you click on that, it actually inputs all of the settings you did and generates a template journal paper. So you have your abstract all written in. You have a little picture of the plot of the prediction put in. You have like the methodology, actually the how many people you had and where you lost people, attrition table. You have information about the covariates, so just summarizing some of the main covariates, so how often they occurred with the outcome, without the outcome. And you can define which covariates you want to include into this. And then you have your plot of your covariates, so you can see how people with the outcome varied from people without the outcome. You have your model performance, you have your ROC plot, your calibration plot, and all the values put in. And then you have a template for your discussion and a template for all your limitations and so on. So hopefully lots of papers will come out of this. So if we go back to...
So please help Mark Suchard get the papers and citations.
Okay, so with the all variables, it's not quite as quick as sometimes would be if you were doing the 5 variable. Sorry? I suspect our servers are being used by everyone else in the other tutorials. Maybe.
So the template, the code, which if I do it in the public instance of Atlas and go to the prediction tutorial and I'm looking at the R code to paste, I don't see the Shiny app invocation, or unless I'm missing something. Can you show which command is that, and then show if we have time while we're waiting for this to finish?
So the Shiny view is this view PRP, and then you put the result in, and it will pop up the result. So once this is run, it's going to take a little bit longer for the covariates. Generally, the covariate construction is quicker than this, so I think that we're probably other tutorials might be using the server. Just kind of put this. So I hopefully should have something open with somewhere. So this is the Shiny.
Where on the forum is the appropriate place to ask for help for the PLP related questions? I never really know if it's a researcher or an implementer or a developer or all of the above.
So any suggestions for that?
Like, is there something you guys look or
I use the research.
great if you have well, like, yeah, if you're like, I have a question and I want to post on the forum, I literally don't know which section on the forum is the most appropriate place to tag a PLP package related question. But let's say I want to ask, who else is using Impala database connectors and solve KDBC? Where would I post that? Like, if that's most appropriate, that someone would find it.
I think that depends on the kinds of questions you're asking. So if it's going to be creative in the forums, right or wrong, when creative, the idea of researchers would be like, you want to ask the question, hey, does anybody want to figure out how to predict stroke amongst people with AFib? That's kind of a researcher question. If you're asking, I'd like to get the technology to work in Impala, then that's a implementer kind of a question. If you're saying, hey, I'd like to add a deep learning module to the package, then that's a developer type question. If specifically you're getting a bug in the software, that would be something we would want to post on the GitHub issue tracker. But I think probably, despite the fact that we have all of these false levels of classification, I think most of the core people are reading every single forum post, so it probably doesn't matter all that much.
So once you've done a model, you can actually go to the view PLP, and this is the output you get for the Shiny. So you'll have the evaluation summary as a table, so you can look at your end of the curve and the confidence interval for the test and the train performance. You can look at your characterization, so this is the outcome and non-outcome incidence, and if you click on this, it actually will tell you what covariate it was. There is options now, this one it must have been an older version, there's options now where you can resize and rescale these based on different variables. You've got your ROC plot, so you can look at your test and your train ROC, the different values, and if you hover over it, tells you the risk threshold for that. and your sensitive specificity. Then you've got your calibration plot, and again, you can click onto that and it will tell you the values. So you can actually see what your average predicted velocity observed was. You've got your demographics, so how well it's calibrated for each demographic for the test and the train. You've got your preference, so this is your distribution. Your box plot, this isn't interactive. Making that interactive was really tedious, so this is just a static one. And then your settings, so you can actually see you did elasticity regression, you did Person split, 25% test fraction. You can look at the variance that you actually use. This is the hyperparameter for the final model. And then you've got information about your cohort ID, your attrition, your outcome ID, and the settings for your population. And then you also have your variable options, so you can see what variables you included. So 1 means it was included, 0 means it was excluded. So this tells you information about what the model looks like. Oh, and your attrition table as well, so where you lost people. At the moment, there isn't anything for the external validation. That's to come soon, where you'll be able to click on the external validation, pick some new data sets, and then see the performance on those data sets as well.
Jenna, you're running slow because apparently I injected the virus into our network.
Oh, really?
So she's going to turn it off and it will be fine. Once he kicks me off the network, then it goes screaming back.
So is that a virus with a new laptop?
It's-
That's ironic.
I am the virus. Keep going, don't wait for it.
We have time. So where's the markdown for the ready for JAMA? Because the plot of where I route the population, I was always looking for that. It was only on the web system.
So this is for generating the JAMA paper. This is the Create PLP Journal document. There's also another Create PLP report, I think I've called it, and that just generates, it doesn't do it in a journal format. It just says, report, here's your test performance, here's your train performance, here's all the plots, here's all the options. So if you wanted to have a record of what you put in as a document, you could use that.
I bet it's going to call a markdown report, right?
It uses.
I'm just trying to find that document.
Let me have a look at what I used. Report to RS is what I use for it. So this is an R package that enables you to do PDFs and PowerPoints and Word documents.
So all the things are calls inside that function.
Okay, so the data is being downloaded now, so it would actually be very quick to train this. So this 10 minutes generally with 10,000 should be 30 seconds virus-free. So and then we should end up with another folder in here. Oh no, it's still fetching the data, which seems to be slow as well. So we haven't actually published any applications yet, have we? So these are the plots you get outside of Shiny. The static plot. So you have the demographic summary, which is slightly different than the one in Shiny. You've got your observed and your expected plot, and then you've got the confidence interval, different age and gender groups. Then you have your F1 measure, so if you want to look at your S1 score across different probability thresholds, then you can have a look at that. You've got generalizability, so this is your test and train to see if you've got a good test and train split. So here it looks like we've got a pretty good test and train split in general. There's nothing that's way out on the top left or the bottom right. Your precision recall plot, so this might be of interest, expecting the model. The predicted PDF for the outcome and non-outcomes. Looks a bit interesting, this one. Seems to be a lot of outcome people, non-outcome people with this prediction. Sorry? And then the predicted distributions is the box plot summarizing the distribution we saw before. Then we see the preference, so this is when it's rescaled on the prediction. So you get a bit of a nicer plot. Then the sparse calibrations. So this is the old sparse calibrations. This is when you've got the 10 points and it does the best fit linear model and the confidence interval of that. But then you also have the one that I tend to look at myself more often is the conventional, which is you have your dots and your confidence interval for those. And then you have your sparse rock plot. And finally, the variable scatter plot. So this is the characterization. And in this case, the variables that are selected in the model are green, and all the other variables are blue and smaller. So hopefully, I think the data's been downloaded now. I should have got the model. Oh, no, it's still running on that. Which distribution would you like?
So why do we have this funny thing that all the no outcomes are at over 10% prediction threshold?
So for some reason, a lot of the outcomes just seem to have that. So maybe they have something in common.
So what does it mean? The people who had no outcome all were predicted to have an outcome at 10%. Is that what it is?
Saying that there was a lot, yeah. So the majority seemed to be either 0 or around 10%.
But if it weren't such a funny artifact, you would like to see a blue hill on the left and the red hill on the right?
So if you had a perfect discrimination, then you should get some separation and normally a bit of a nicer distribution. These seem to be interesting.
What we've actually observed, though, in most of the studies that we've done is this is the same plot that those of you who have seen what Martine's been doing with population level estimation, where we look at the propensity score and we see the distribution. You see that nice continuous blue and red. Remember, that usually is generally we're comparing two treatments, and we're predicting between treatment assignment, and so you have two groups that are very large, and most of the time they're not notably different. So you see overlap, but a little bit of difference. In contrast, for most of the prediction problems that we've been working on lately, you're usually taking some general population T, so let's say all the people with atrial fibrillation. And then you're trying to predict the outcome stroke. So what this is representing is people with the stroke and people without the stroke. And very, very commonly what we're observing is that the people without the event, they all tend to get very low predicted probabilities because it's pretty easy to figure out who's at low risk. Whereas the people with the event tend to be more continuously distributed because some people were highly likely to have the event and some people got the event even though we didn't see it coming. And so I think this is just a small sample, kind of extreme example, but when we do see this, instead of thinking about it as like blue spread across and red spread across, usually what it is blues pushed over to the left and then red's kind of continuous. And what we want to do is do as best we can to move those reds to the right.
And that's if the outcome is rare compared to no outcome, right?
So there are two plots that Jenna showed. One was based off of the predicted probability, and in that one everything will be pushed to the left because that's on an absolute scale. The other one was the preference plot, so that's actually if you assume that those are equally weighted classes, meaning that if the outcome had been 50%, that's what it would look like. But even in that extreme, what we typically have seen in the types of prediction problems we've been working on is there's usually a large fraction of people for which you can predict that they are at extremely low risk, and those are the ones that kind of get pushed to the left. And I don't think that I think this is probably in healthcare going to be a general phenomenon. There's a large number of people for which we should be able to really quantify and say you're at low risk, but figuring out all the people at high risk is actually a challenge. So as Jenna presented in her plenary talk on Wednesday, you saw that one of the successes, which is you could find half of the events in a small fraction of the people, but the other half of the events were kind of scattered throughout the rest of the data. But what's potentially even more impactful for public health is to be able to say half of these people are at extremely low risk. So 1 in 2 people, we could say you shouldn't really worry as much about this. And I think that actually from a public health impact, that's going to be one of the more exciting areas for us to focus on.
How are we doing? So is it break? So should we have the break and then hopefully the data will be extracted by then?
That's 50 minutes
Okay,
break.
so now it's being extracted. So this is going to be quick now, and then you'll see the performance.